Ever pondered if we could reach the speed of light? It's a question that has intrigued scientists and laymen alike for centuries. The sheer concept of light speed, an unfathomable 186,000 miles per second, has been a subject of endless fascination. It's not just about the numbers, but the possibilities it presents. Imagine, if you will, the ability to traverse unimaginable distances in the blink of an eye. So let's unravel the mysteries of light speed. To comprehend our question, we first need to understand what the speed of light is. A cornerstone in physics, the speed of light is the fastest speed at which information or matter can travel. It's an astounding 299,792 kilometers per second. That's so fast that it could circle the Earth more than 7 times in a single second. This isn't just a fascinating fact, it's a universal speed limit. Nothing in the known universe can travel faster. This limit is so fundamental that it underpins our understanding of space and time themselves. It's the heart of Einstein's theory of relativity and plays a crucial role in technologies we use every day, from GPS navigation to medical imaging. The speed of light isn't just a number, it's a fundamental pillar of our understanding of the universe. To further grasp the speed of light, we must delve into Albert Einstein's theory of relativity. This revolutionary theory, proposed in the early 20th century, radically reshaped our understanding of the universe. It tells us that space and time are not separate entities, but rather a single fabric known as space-time. But the real kicker is this. The theory also suggests that nothing can move faster than light. Now, let's imagine for a moment that you are aboard a spacecraft accelerating towards the speed of light. According to Einstein's theory, an interesting thing begins to happen. As your speed increases, time starts to slow down relative to an observer back on Earth. This phenomenon is known as time dilation. The closer you get to the speed of light, the more pronounced this effect becomes. If you could reach the speed of light, time would theoretically come to a complete stop, but only for you, the traveler. Back on Earth, time would continue to tick away as normal. This is a mind-bending concept, isn't it? The idea that the flow of time is not a constant, but something that can be altered by speed and gravity. It's one of the most fascinating aspects of Einstein's theory and a key to understanding why we can't exceed the speed of light. In essence, as we near the speed of light, time itself becomes a variable. Now, armed with this knowledge, we return to our initial question. Can we achieve the speed of light? A tantalizing thought, isn't it? Imagine zipping across galaxies in the blink of an eye, a concept so often romanticized in science fiction. Yet the realities of physics paint a far more complex picture. The primary hurdle in reaching the speed of light is the energy requirement. According to Einstein's theory of relativity, as an object approaches the speed of light, its energy requirement increases exponentially. To put it simply, the faster you go, the more energy you need. And at the speed of light, this energy requirement becomes infinite. But that's not all. As we approach light speed, another strange phenomenon takes place. The object's mass begins to increase, again exponentially. This is known as relativistic mass increase. So not only would we need an infinite amount of energy to reach light speed, but we would also become infinitely massive in the process. And then there are the paradoxes. One of the most famous is the twin paradox. If one twin travels near the speed of light while the other stays on Earth, time would pass more slowly for the traveling twin. Upon their return, they would find their earthbound siblings significantly aged, while they themselves would have aged very little. These are the mind-bending implications of time dilation at near light speeds. So we find ourselves caught in a cosmic catch-22. The laws of physics both tantalize us with the possibility of light speed and simultaneously bind us within the confines of our current understanding. It's a monumental challenge, yet it's these very challenges that push us to learn, to explore, and to dream. For now, the speed of light seems out of reach, a boundary that humankind has yet to cross. So, while the speed of light remains an intriguing concept, it appears that for now it's a boundary we cannot cross. Our journey towards the speed of light may be fraught with impossibilities, but it doesn't dampen our fascination. We've delved into defining the speed of light, explored its deep connection to relativity, and grappled with the tantalizing question, can we achieve it? This elusive speed holds a prominent place in our physics, shaping our understanding of the cosmos. So while we may not be boarding a light-speed spaceship anytime soon, the quest for understanding continues to propel us forward at whatever speed we can achieve.